Hello, good morning, good afternoon, or good evening. We are about to start our webinar. Please stand by. Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's webinar, When Safety is Key, Addressing Safety Critically in Modern Industrial and Transportation Systems, brought to you by DiSTI Corporation, CoreAVI, and NXP Semiconductors. This is Toño Hernandez from the NXP Automotive Processing Distribution Marketing team, and I will be your moderator today. Discussing today's topic is Christopher Giordano, Vice President of UX and UI from DiSTI Corporation, Lucas Pricek, Field Application Engineer from CoreAVI, and Pat Stilwell, IDITAMX Product Manager from NXP Semiconductors. During this webinar, you will see the benefits of safety critical graphics, UI, and hardware. You will also understand the challenge and solutions for implementing full safety critical system stacks. And finally, you will see some best practices for accomplishing system certifiability. You can participate along with the session by asking our presenters a question. Just type your inquiry directly on your screen question box. We will have a dedicated Q&A session to answer most of them at the end of the presentation. We are contacting you after the session if our speakers cannot provide an answer. So without further delay, let's address safety criticality in modern industrial and transportation systems. Christopher, please take it away.
Many thanks, Tonio, and thanks to everybody for taking the time to attend the webinar. My name is Chris Giordano, I'm Vice President UX UI at the DISTI Corporation. I'm going to be talking to you first about the graphical layer of safety critical HMI, and then we'll be stepping down into the stack as we move into CoreAVI and NXP. So just a little background on DISTI Corporation. We've been around since 1994, located here in Orlando, Florida. We've got over 20 years of functional safety capable experience in development of HMI, UI, commercial tools. We've got over 700 companies around the world in actually 47 different countries now. So quite a bit of growth for us there. Just a real quick list of our customers here, some of our higher end customers. You'll notice everybody from aerospace and defense customers out to medical, rail, and of course, automotive as well. A few of our latest successes here, we're doing quite a bit of work on clusters and HUDs with Mobis now. We are adopted for all the vehicles at Jaguar Land Rover. We're in recently agricultural systems with Fendt, agricultural control systems with Fendt and Topcon. And we also recently had a new adoption by Boeing for the latest T-7A Red Hawk trainer jet for all the avionics and the training systems, as well as from Boom Supersonic for the avionics and training systems of the next gen supersonic aircraft. But that actually transcends into a number of other markets for us as well. So we do quite a bit in power generation, medical, agriculture, and of course, aerospace, defense, and automotive. So this comes with our third-party ecosystem. We have to have a very powerful ecosystem of partners that we work with, well over 50 different companies, lots of OS and RTOS providers, lots of technical providers, and we've actually been part of a number of different standards committees over time. Our GL Studio supports safety critical capable DO178 displays, ISO 26262, medical, industrial, rail, and even NQA1 for nuclear facilities. So again, we've got quite a bit of background on the functional safety side of things. So let's take a quick look at why is that important in your software reliability. So when you start looking at a lot of these newer devices that are out there on the market, you start to look at the lines of code in the devices, everything from a pacemaker to the space shuttle, out to a fighter jet in an era and a modern automobile. You can see everything from 100,000 lines of code up to 100 million lines of code. So it really depends on what you're starting to build. And of course, the more complex these systems get over time, the more systems you have to control, the more connections you have to make, and the more powerful the hardware needs to be in order to handle that. And as we know from Moore's Law, you're doubling your transistors every 2 years. It really kind of forces OEMs down the path of having to take advantage of and get the best possible technology on their hardware. So if we take a look at why is that important? Well, let's use automotive as an example. So bad software can cause very serious problems, okay? So if you develop something that's unsafe, catastrophic failure can lead to death, can lead to serious problems. This is where functional safety comes in very important. So as these systems become more and more complex, we're adding more software to the system. That software needs to be developed correctly. Now, despite setbacks like the last slide that I was showing, if we stick with automotive, quick example, you take a look at the number of people that in 2017 thought that self-driving vehicles would not be safe. And if you move to 2018, you see that that gets significantly better for self-driving vehicles. This is because we learn from accidents, right? We continue to make that technology better, safer, stronger, and more efficient to make, right? So when you're looking even just at autonomous vehicles, that level of safety criticality is really demanded in these different markets. So why is it important? Well, ultimately, functional safety is there to save lives, okay? But along with that, you get the added benefit of securing systems, having more secured systems, having more reliability in your systems, which builds more comfort with your brand and your technology. So in order to get there, you need a solid safety plan. You need a good safety culture within your company, and you really need to be ready for things that you don't know are going to happen in the future. You really need to future-proof your technology. So if we take a look at our specialty in the guise of functional safety software, we stay towards the top of the stack, the HMI and the graphics layer, okay? And as we see a lot of the OEMs and tier ones that are out there, a lot of the development suppliers, there's really a race to the best looking UI. So it's very difficult for a user of technology to be able to understand the OS, the graphics stack, the hardware. But when you look at the UI, that's what everybody touches and sees and interacts with. And so that is the branding that comes across for different manufacturers of different devices, be it medical or agricultural or industrial of any kind. So the tools that you need really require a high level of capability. You need to be able to have support for ASIL content, non-ASIL content. You need to have functional safety requirements built in. You need to have mixed criticality so that you can continue to try to drive your costs down. So there are standards out there already that have been written for just about every market. Some are more mature than others. You look at avionics, for example, which has been around for 25 plus years. And then you look at And then you look at automotive, which is relatively new. So these are all taken into consideration for the HMI and the UI. So if we take a look at the mixed criticality as the path forward to driving costs down. So what is mixed criticality? Well, mixed criticality is the ability to have both a safety layer and a non-safety layer composited together. And if you do this from the same design, it makes your development process significantly more efficient and more effective. So this is a high-level definition of what we mean by mixed criticality. So there's a few challenges there. So the challenges around mixed criticality have to deal with, well, how do I composite those graphics, right? The functional safety is also for the entire system. It's not just for the individual component of the HMI. So your RTOS, your hardware design, any other middleware that you're using, all of this has to be functional safety capable in order to have the system be certifiable. The HMI is a small part of that. So using open source technologies like Linux, for example, could be a challenge. It's not insurmountable, but certainly could be a challenge. Certainly creates a lot of extra code base for you. When you look at the previous slide that showed the difference between a pacemaker at 100,000 lines of code and a modern vehicle with 100 million lines of code, well, a lot of that has to do with the fact that that vehicle is using open source software and has a lot of software in it that it may or may not need. We've seen in different markets lack of experience, lack of industry expertise as this market starts to grow into the functional safety market. That, of course, continues to get better very, very quickly. As I mentioned before, there's a lot of industries that are very mature in functional safeties and a lot of industries that are just coming up in functional safety. So then we talk about hardware can be a single point of failure unless you design it properly for your production. And then there's a lack of standards and practices for adhering to, which again continue to iterate, come out with new versions and get more efficient, become more efficient. And then the last piece is that there is a lack of a singular certifying authority in some markets. Some markets are very, again, mature. You look at the FAA, for example, with avionics. An aircraft will not fly unless it is certified for specific systems in a very specific way. But you look at, for example, automotive, and they have very good recommendations on what to do, but no one single authority that says your car is not going to drive on the road without meeting these standards. So if we take a close look at the needs for HMI in developing functional safety, you really need to have a tool that supports both QM and ASIL content. Otherwise, your ASIL content ends up becoming hand-created, which is very time-consuming and difficult to maintain. What's important is your reliability, your scalability, that the content is safety capable, and that the functional safety design tools are able to build what you want for today and into the future. So you need to be able to take advantage of the latest hardware capabilities. And in a mixed criticality setting, you need to be able to have support for multiple displays on a single setting. And so that's one of the things that we're actually going to be talking about here. If you look at the graph on the right-hand side, the high-level application workflow is where we sit. The middleware driver and OS is where we start to hand things off to, for example, CoreAVI as we step down into that graphics stack. And then, of course, the hardware at the low end of the system is all going to be NXP a little bit further down the line. So we were actually able to demonstrate this live this year before everybody had to start working from home. We were at CES 2020 over in Las Vegas and, of course, in Nuremberg at Embedded World. what we were able to show was a mixed criticality workflow where from the same design, you have safety content, Acell rated, and QM content, which would then create the two separate applications and with a single push button touch, be able to iterate in less than 60 seconds for every iteration of the application. Now, this was able to allow us to realize a pure safety layer and a much more complex 3D animation ES style QM layer underneath it that would be in the same exact design file and pushed out to target, as I mentioned, in less than 60 seconds. So the architecture for this was running on a IMX8 Quad Max MEK. This was on Green Hills Integrity. And we had several different virtual address spaces. One was safety critical, the others were not. And we're able to composite that and push that out to display. And so I'd really like to thank our partners on that, which was NXP, CoreAVI, Green Hills Integrity, to allow us to be able to prove this case study in the public eye. And so what that really gives you is a significant workflow efficiency, future-proof your technology. It allows you to really put anything that you want in for your Acell-rated content. There's no real pushback on the ability to do any type of Acell-rated content with this methodology. And because we're giving you a better runtime performance as C++ code generation, it really lowers the level of hardware that's needed, which lets you lower your bill of material. Less ECU lets you lower your bill of materials. But it also gives your designers, from the UX and UI standpoint, more tools in their tool bag to work with as well. So you can preview a live video of that out on our YouTube channel. This will be in the presentation as it rolls out as well. So as we start to close this out, what are really the benefits that you get from a partnership that we have like here on this presentation? So DISTI, CoreAVI, NXP have been partnered together for many, many years. And we have pre-configured architectures. We assist people in going through their certification efforts. And of course, you know, you get the proven solution through all these different markets and all of these different industries for the best possible reliability. So in closing, we'd like to highlight that we, as of yesterday, they let us know that we're now a member of the ARM Functional Safety Partnership. So GL Studio is now a safety verification has been completed at ARM, and we're part of the partnership. We've also released a new white paper on safety critical in autonomous vehicles. I urge you to go and get your free download for that today. And with that, I will let you step into the stack a little bit here with CoreAVI, and I'll hand that back to you, Tonio and Lucas.
Thank you for that, Christopher. A reminder to our audience, you can type your questions if you have in the question box right there. At the end, we will have a Q&A session for reply all of those. So Lucas, we are ready for you now.
Okay, thank you very much, Chris and Tonio. So I'm going to be talking about CoreVI's position in this tech stack that Chris was mentioning, where we fall in kind of the middle layer, and a little bit about who CoreVI is and what we provide to the industry. So CoreVI has existed as a company for a number of years, and we've been mainly focused in the safety critical avionics market, but we've also moved into other markets such as automotive and industrial IoT. We're actually deployed in over 130 programs in 20 different countries. And we really focus on providing GPU accelerated solutions, whether that be safety critical OpenGL graphics or GPU compute. So in the automotive market, we kind of enable what I was talking about before, the use of safe graphics and compute on vehicle subsystems. We're a partner with a number of people in the industry, such as ARM and NXP from the hardware side, and then as well with DISTI from a software perspective. We're really accelerating innovation by providing a platform for safety critical software to exist on. So we provide this safe interface into the hardware. So in the automotive sector, our key value proposition is that we are a leader in open GPU safety standards. So we're a member of the Kronos organization. And so those of you who are not familiar with Kronos, they're the standards body that defines OpenGL, Vulkan, OpenGL safety critical, Vulkan safety critical. We actually chair the safety critical subgroup inside Kronos for the Vulkan safety critical standard. So we have a really unrivaled record for formal safety verification as it relates to GPUs and the things GPUs can provide inside vehicles and industrial systems. In the safety critical avionics market, we have a 20+ year proven track record of supplying major military and commercial avionics systems with safety critical accelerated GPU solutions, whether that's for graphics or compute. And we're have major partnerships with key suppliers in the avionics industry, including NASA, Honeywell, Boeing, and all of those guys. And we're really a single supplier for safety critical solutions. We give you everything that you'll need to start getting safety critical code running on your GPU. A few examples of platforms that we're deployed on in the military. So there's a number of aircraft and helicopters and ships that we are currently deployed on. In the industrial IoT market, again, we are providing safety critical GPU accelerated solutions, building on years of safety critical knowledge captured in both the aerospace and defense market as well as automotive. Just to get really into the meat of the presentation, I'm going to start talking about choosing the right platform and what that platform looks like and where CoreAVI and the other partners in this presentation fall into. So the platform that most of you attending are probably looking for is something that can meet all your current application requirements, is adaptable to future requirements as more and more solutions want to be reused in different applications as much as possible to eliminate R&D cost, development cost. And you really want to focus on your key part of the stack. So you don't want to worry about the underlying hardware, whether or not you can certify the operating system, whether or not you can certify the graphics driver, your underlying graphics tools that you're using to build your application. And so from that perspective, there's the NXP IDITAMX 8 as an underlying hardware platform. It provides a Vivante GC7000 GPU. It's low TDP, which means it fits in for a lot of applications. And it also has hardware partitioning support. Patrick is going to talk about this more in his presentation about how the IMX 8 Quad Max actually has 2 GPUs on it that can be isolated from each other and run independently. Of course, there's the CoreAVI graphics driver running on top of the real-time operating system. So we have a graphics driver available for the GC7000 GPU on the IDITAMX 8 Quad Max with support for Vulkan SC and then our OpenGL SC1 and SC2 graphics libraries. And then we also additionally have support for general purpose GPU compute through Vulkan compute shaders on top of our driver. And lastly, from what you just heard from Chris, there's the DISTI HMI layer where they provide a set of tools to build your own application on top where you don't need to worry about the complexities of building HMI applications. Next, I'm going to go into the system requirements you might see for a typical safety critical vehicle system. And Chris mentioned a bunch of these things before, more and more common requirements we're seeing across all these different industries. So there's the need for multiple applications running on the same CPU where there's different levels of safety. So this is this mixed criticality idea. There's the need for single large area displays to be used for both high criticality and low criticality content. So you want a single display that's capable of showing all the content you need for your application. Additionally, there's the use of general purpose GPU compute. So more and more GPUs are being used as co-processors to offload tasks from the CPU that they are more efficient at executing. So these are these highly parallel operations, things like image processing, artificial intelligence. More and more, we're seeing a need to offload this type of computation onto the GPU. And lastly, there's the requirement for certification. So whether that be DO 178C for the aerospace market, ISO 26262 in the automotive market, or IEC 61508 in the industrial space, there's more and more needs for certifying systems and having software that you can rely on that is actually certifiable. So all of this together, we have a system that we need to provide multi-application support on a single display with the ability of general purpose GPU compute on a certified system. So putting this all together, one might come up with a naive system architecture that looks something like this, where you have your OS components with your graphics driver, applications that are built on top of DiSTI's GL Studio and other HMI tools, and then your underlying hardware platform with the NXP IDITAMX 8 Quad Max with the GC7000 GPU. So there's a number of issues with kind of this naive approach, and some important concepts that are commonly missed that we at CoreVI see our customers struggling with and needing support and finding the correct solution so that they can build highly reliable and powerful and fast modern automotive systems. So the first issue comes with combining graphics applications onto a single display. So we need to show both safety critical content and non-safety critical content. So in Chris' presentation, the QM and SC content. And we need to make sure that the safety critical content is not being obstructed or being hazardously misleading in any way by other content on the screen. And so this naive architecture doesn't offer any guidance on how we can achieve this single display solution. Additionally, there's the specific mention of an OpenGL graphics driver. And OpenGL SC does not provide any support for general purpose GPU computation. And currently no vendors provide any extensions on top of OpenGL SC that provide access to compute shaders. Another problem is the safely sharing of the GPU across multiple applications with different criticality levels. So if you have one hardware device, in this case the GPU, shared across multiple different applications, you need to make sure that those other applications that are not safety critical in the system are not interfering with the safety critical applications in any way. So this could be in the space domain, such as corrupting the frame buffer or modifying the frame buffer or graphics state of another application. And this can also be in the time domain, such as using more graphics time than they've been allocated and not allowing the safety critical content to run on the GPU. So a more improved system architecture would look something like this, where you take advantage of modern hardware partitioning features to build virtualized partitions, where you have each application running in user space inside their own partition, or each application safety level running inside their own partition, so that they're isolated at the hardware level. We can also introduce this concept of a GPU manager that manages access to the GPU and ensures that the GPU is being accessed safely across multiple applications, and possibly even restricting access of non-safety critical applications to not overutilize the GPU. And then you have your OS components and hardware platform as well, where you have a real-time operating system that's certifiable and a underlying hardware platform that has safety features incorporated into it. So the reason this system architecture is improved is because virtualization helps keeps the different applications isolated. So this allows us to safely share the hardware across different applications, relying on hardware partitioning features to make sure that there's no physical way one application can interfere with another application. And we can also take advantage of this hardware partitioning to facilitate safe access to the GPU using an additional application known as a GPU manager that would exist within your health monitoring partition. Next, there's this introduced concept of the compositor. So Chris mentioned this before. you can separate your safety critical content and non-safety critical content into their own layers and have a compositing application that's responsible for taking both this content and combining it onto the final display. The Opengl SC standard has an extension known as the EGL compositor extension that provides this type of compositing functionality. And in Vulkan, there's the VKKHR display extension as well that allows you to composite your content. So now you can introduce this, I'd say, third application that is responsible for the display and reads the frame buffer from the safety critical and non-safety critical content and composites it onto the final display in a way that's not hazardous or misleading in any fashion. Next, there is the introduction of a Vulkan safety critical graphics driver. And the Vulkan driver provides low-level access to the GPU. And the benefits here is that it allows you to extract better performance out of the system by having lower level access to the GPU in a portable fashion, but it also introduces compute shaders that allow you to write general purpose GPU compute applications on the GPU. And one of the cool things about this is since Vulkan is such a low level API, it lets you build hardware accelerated versions of compute libraries on top of it. So a version of OpenVX or OpenCV could be built with an underlying Vulkan backend, Vulkan compute shader backend, where you have a safety critical platform to deploy computer vision applications and AI applications on a GPU that are hardware accelerated by the GPU. Next, there is the Opengl and Opengl SC2 graphics drivers that allow HMI applications such as DiSTI's GL Studio to generate code that can run on the GPU. And the CoreAVI Opengl SC1 and SC2 product built on top of our Vulkan driver, allowing you to take advantage of legacy systems or tools that rely on Opengl implementations, and then use Vulkan for anything new and flashy you want to build yourself, such as GPU accelerated compute. Lastly, the software stack I'm describing right now is all certifiable products. Each component has evidence available on the software side for DO 178, ISO 262, or IEC 61508. And to kind of conclude and go back to what Chris talked about the partnership benefits, really what we're providing here is a reduced time to market, as the entire solution stack is being provided to you, and then you only need to build your application on top of that. And you're relying on industry proven solutions. So this isn't something that you're trying out for the first time. It's never been proven before. You're really building on the shoulders of giants to make sure that you're running on a solution that is proven and is safe and is low risk. And between all of us partners, there's decades of experience working with safety critical systems. So thank you very much for your time. I'll hand it back to Tanya now.
Thank you, Lucas, for that. Let's move forward. Last but not least, we have Pat that will talk about the IDITAMX family. So take it away, Pat.
Okay, thanks, Tanya. Thanks, Lucas and Chris, for your presentations. Very, very helpful information. So what I'm going to discuss here is from an SoC level and NXP sides on what solutions we offer to our partners to help them really develop their overall platforms. Just from a historical perspective, really product longevity is one of the key factors in a lot of our customers designing our SoC, the IDITAMX 8, into their applications. They want these products to be available for 10 to 15 or even 25 years as they develop industrial and automotive applications. And really, from the early days of Motorola into Freescale and now NXP, the history of the IDITAMX family has gone on for, we've been in the marketplace for about 10 years now, 10 to 12 years, and we continue to improve as we start certainly moving into functional safety as a deliverable to all of our OEMs and our tier ones. So really from the IDITAMX side, availability is key, scalability with the different product lines that we have across many OS platforms, and then of course supporting and enablement with our partners. So really what I wanted to talk to here is the IDITAMX. Let me just back up a little bit here. Talk about the IDITAMX 8 and 8X subsystem reuses for hardware. The Quad Max is really the superset of our high-end deliverables. The chip itself has 4 A53s, 2 A72s, 2 M4s, and as Lucas had talked to earlier, 2 GPUs that a lot of our partners take advantage of, and then multiple display controllers. And then as we move down into the product line with the 8X is more of a mid-range offering with 4 A35s and with a single M4, and then multiple display options, as you can see on the bottom with LVDS and MIPI CSI and DSI. So from a qualification spec, really when you start designing into your platform, you do have to exactly know what your end use case is, your power on hours, and really what you have to offer to your customers as well. So from an industrial standpoint, really our 10-year life is the expectation is it's always powered up 100% of the time, -40 to 105 TJ. And then from an automotive side, which is a little bit wider temperature range, really it's a 10% duty cycle on, 15-year life at -40 C plus 125 TJ. So these are the industry standards that we meet and complete our qualification levels as we move forward. And then from an industrial IoT, really it's a very broad portfolio, and our offerings are very wide, not only in the consumer level for some of our IDITAMX family, but of course into high-end industrial and automotive. The IDITAMX family is in 9 of the 10 largest OEMs in the world, which reach across many regions, Asia, Europe, as well as North America. So really, it's not only a safety, functional safety offering, but really it expands into security and of course reliability as we move forward. So as Chris and Lucas discussed, these functional safety platforms are becoming more and more complex, certainly from a software side. And with the IDITAMX 8 hardware, we really hope to make that much easier from an R&D development cycle time. So we talked a little bit functional safety, but what I wanted to hit on first is really our offering from a security level. We have secure boot on the chip, which is really a component of our high assurance boot program, and secure on-chip security controller, HSM, we call it a SEIKO. And really this is security you can put into the ROM, and it's really for authenticating the SEIKO firmware on the chip. And then we have secure storage, OTP, master key, which provides the base key from which all this non-volatile storage keys are derived. And then key protection, which we have really separate presentations on all of our security offerings, but really this is boot time acceleration and hashing functions that can take place along with crypto key protection. Key revocation, if you really had to move a public key around, if it needs to be replaced, that's possible. And then of course for secure debug, authenticating first the person that's going into debug mode, and then really what port you want to go through using our OTP fuses. So this could be JTAG or other boot time deterministic values that you want to be able to read back as you're debugging the components. And then we have, which is very important, tamper detect, both from a hardware and software level. We have up to 10 tamper detect pins. And then from a software level, you can actually detect SNVS, with security violations, as well as thermal protection as well. So that's key in any kind of end use case that is being used. And then virtualization and partitioning of the hardware itself with the softwares using system hypervisors if those are required or used, which are very important. And then lastly is the manufacturing protection that we put in the device from a fuse standpoint. NXP puts in the public key, and then there would be another fuse in there for the OEM where they can put in their secret keys as you go through your design cycle. So this is a high-end description of really what's in the SEIKO, the HSM, as I discussed. Really, it's a very energy-efficient module. It's an M0, supporting 133 megahertz. There's an interrupt controller with 32 IRQs, security control through authenticated debug as well. And then some fabric switches in there with shared peripherals, which again, we could get into, but really this is as we move forward as the most important things really within the vehicle and within industrial applications, having an on-chip HSM with all the different security channels that are needed. The IDITAMX 8 and 8X have this in place for all your uses. So as we move forward, when this was designed about 5 years ago, and as we get into the marketplace, this is the hardware partitioning. I know Lucas talked to it a little bit from a software side and a stacking side. And really what this is, as you can see, you can split the chip up really into 2 different SoCs if required. You have this is an example of the A53s alone running Linux. And then on the right-hand side, you can see the A72s maybe running on an Android platform level. And then, as we said, we have multiple M4s on the chip, and you can really run a third OS in parallel, maybe using RTOS for some of your failover functionalities that may be required, certainly from an automotive standpoint. So you can see on the bottom there where the GPUs are really, this is not only hardware partition, but it's software partitioning as well. Once you let the software guys do what they need to do. And that's really been important in the past. You've been able to do software partitioning or maybe even hardware partitioning separately, but really with the IDITAMX 8 and 8X, you have both those options. And really that's why these can be designed into safety critical systems, including avionics as we begin to move forward. And then from a system development, really the NXP's value proposition, we have multiple MCUs that are within our internal Safe Assure program in NXP. This is an internal auditing process where we cannot move forward until we do our internal auditing ourselves. So independently, we have a group that checks not only on the robustness of our functional safety features, but of course, completing our reliability and qualification robustness, and as I talked earlier, the security features. So this is the overall unlocked value propositions that we are able to offer to all of our customers. So for the IDITAMX 8 and 8X, these are not Acell rated SoCs, that they are quality managed. You know, when we did start this design cycle 5 years ago, the safety critical features were just coming to fruition. So as we move forward, we have multiple plans for safety islands on our future products that are coming out here within the next year or two. But on the 8 and 8X, quality managed SoCs will be designed into a platform. And then of course, the platform overall is what gets certified, you know, once all the hardware and software is in place, and then the OEMs and the tier ones themselves are the ones that would get the platform certified. But the IDITAMX 8 and 8X definitely has the hardware required to make that process hopefully much easier for our customers. And this, it's safety element out of context. Is the IDITAMX 8 a safety element out of context? The answer is no. However, it still gets included into the bigger SEIKO as a quality managed device on an overall platform. So it doesn't mean it can't be designed into an overall platform, because, you know, we are an embedded device. It was not designed for a specific application, and really that's where the safety element out of context comes from. So over multiple industries is what this is designed into. So from a high level, and I know Lucas talked about this a little bit as well, the 8 Quad Max, as I discussed earlier, is our superset part. As you can see, the multiple A53s, 4 A53s, multiple A72s, a couple of M4s, 2 GPUs, so multiple screens. This can run up to 4 displays in parallel, and of course some of your hardware separation and virtualization can be used in that respect. And then of course with vision processing as well, as we see a lot of this machine learning and AI coming very soon to us, already designed into some camera-based systems in vehicles as well as other industrial applications. And then the 8 Quad Plus is a spin-off from the 8 Quad Max. It's really eliminating one of the Cortex A72s. And then the second set of the IDITAMX 8 family is the 8X. This was launched in April, both from industrial and automotive. And as you can see, it's got 3 product families here, along with the multi A35 offerings, Cortex A35 offerings, plus M4s. So as you can see, it splits it into a high end, and then you have the mid-range with the DX. And then at the lower end of the process is the 8DX, which is a little bit more valued for some customers if they don't need a full featured part. And of course, ECC, error correcting code, which we have on the product line, as well as other memory interfaces. So again, this is qualified at industrial and automotive for their duty cycle ranges that I discussed earlier in the presentation. And then really, for machine learning coming soon, of course, we do have multiple designs into different types of machine learning systems. And really, this starts in the grocery store that you go to on a weekly basis, all the way through some high-end compute systems using the cloud. And really, it's about moving all that data and information as fast as possible to go out and make a decision and then get that back really to the operator of either some machinery or in the vehicle itself. So IDITAMX has multiple offerings. The low end edge compute systems for IDITAMX 6, which I believe a lot of you are most familiar with. And then as we get into the mid-range of computing systems, we have the IDITAMX 7 and 8X offerings with integrated DSPs. And then the high end for the 8 Quad Max and Quad Plus, which we talked about earlier. Really, this is something, one of the products that you would need in order to move lots of information, either within the vehicle, within an industrial application, or to the cloud and back as well, for like a smart cities type environment. So lots of offerings, lots of object recognition, which are in cars nowadays, using camera-based systems. And so this is the range of offerings that we have from a scalable level for IDITAMX. And then this is, as I discussed, the automotive edge computing, really getting those machine-based systems and camera systems. How do you collect the information? What do you do with it once you detect it? And from a neural net classification, what kind of information do you have, and how quickly can that machine make that decision? And the 8 Quad Max family is the one product line that we have that can make these decisions required in the industry. So just from an overall, again, scalable system, 10 to 15 year lifespan availability on our product lines. multi-sensory, and of course, scalable and portable software among all the different product lines in mobility applications or in automotive and industrial. So we are sampling now for all of our customers. So if there's any questions in that, just contact me directly. Thanks, Tonya. I'm done for now.
Thank you, Pat, for your presentation. A reminder to our audience is that you can type your doubts right in the question box on your screen. Our speakers will answer as many questions as possible. We will contact you if they cannot respond or the time ends. So we have a couple of questions already. So the first one is, how are you able to have Opengl ES and Opengl SC in the same design file?
Yeah, I think that one was for me, Tonya. Can you hear me okay?
Yep, we can hear you.
Yeah, so from the GL Studio side, we actually have what we call a safety critical container. So our solution has two separate code generators and two separate runtime libraries. One is for standard QM content, one is for ASIL content. And when you put the content into its own SC container, the GL Studio tool automatically recognizes that and will generate the two separate applications for you to composite to push out to display.
I think there's a CoreAVI portion to that question as well. So in systems where you can have partition GPUs in that there's either multiple GPUs or a GPU that can be split into multiple components, something that we can support if the hardware hypervisor has that is running our driver on only one of the partition GPUs. And then so you can have the our safety critical driver running on the partition GPU, and then some commercial driver, either like an open source Linux driver or a driver from the graphics vendor themselves providing Opengl ES support on the other partition GPU.
Absolutely.
Okay.
Yeah, great.
Thank you guys for that answer. The next question we have is, when do you anticipate that the Vulkan SC standard will be ratified?
So I think that's a CoreVI question there. So there's only so much we can say about the Vulkan SC standard from within the Kronos organization. I will say that Kronos has been pushing for there to be at least 2 independent implementations before a standard is ratified. This isn't always the case. Opengl SC2 was ratified before there were 2 independent implementations of it. But I think that may be a requirement. That does not stop CoreAVI from supporting Vulkan SC as it currently stands within the organization. We have an implementation of not the ratified standard since it's not ratified yet, but of our interpretation of Vulkan SC from as a Kronos member, and we can provide the information about what we support to customers and help them work in a safety critical subset of Vulkan.
Okay, thank you, Lucas, for that. We have another question. For the IDITAMX 8, are the products launched in the general market?
Hi, thanks, Tonya. Yes, actually, the IDITAMX 8X and the 8 Quad Max are both available from a general market. The 8X itself launched industrial and automotive in April, and then the 8 Quad Max has automotive qualification has launched, and the industrial side will launch in January, this coming January.
Okay, thank you, Pat. Next question. In the challenge slide, you mentioned a lack of a singular certifying authority. Can you define that a little bit more?
Yeah, I think that one was a DISTI question. So that was basically meant to be a comparison between some of the more mature safety standards that are out there and from one market to another. So I'll give you a good example. If we look at avionics, right? an aircraft shall not fly until the FAA defines that it is safe to fly, right? They're going to go through in all of the verification, validation, third-party tests, make sure you followed all your processes and procedures and everything's mapped back to the original requirements and. However, if you look at something like automotive, you've got the ISO 26262 standard, which is still relatively new. I think it was November of 2015 or 2014 was it that it came out. And it's a great set of guidelines to develop to a functional safety standard, but there's not really a singular authority that says your car will not go out on my roads unless I insert here what we did with avionics. So I think that it's mostly about differences from market to market and levels of safety criticality that's required that kind of talk about the need for a singular certifying authority. Does that make sense?
Yep, it does. Thank you, Christopher, for that. Next question. I thought the IDITAMX products were Acell rated. Can you clarify?
Yeah, thanks, Tonya. Yeah, the IDITAMX 8 family do not have Acell rated products. As I discussed, they're quality managed products, and really, you know, when you're an Acell rated product, the design has to be, of course, completed and goes through our 26262 process, as discussed earlier. But the IDITAMX 8 and 8X family were not targeted for Acell at that time. So really, it's an overall component and overall system certification that takes place, and the IDITAMX 8 is just part of that. So it's a quality managed device with, as I indicated earlier, we have future projects coming out that will have some safety islands to meet Acell A or Acell B qualification standards.
Thank you, Pat. Next question. Does CoreAVI need a POSIX conform RTOS?
Thank you very much for the question, Antonio. So CoreAVI actually does not require a POSIX conformant RTOS. So we can obviously run on a POSIX conformant RTOS, but we also run on ARINC 653 conformant RTOSs, and we've also ported our software to run on bare metal systems. So there's no RTOS, maybe like a minimal threading library provided on the system. So there's no requirement for us for a POSIX conformant RTOS.
Okay, thank you for that. And last question, because the time is running out. Can we get a live demonstration of the mixed criticality and one-touch deployment workflow?
Sure. Yeah, actually, if you look in the presentation, there's actually a link to our YouTube channel that released a contiguous live video of it. And we can certainly arrange for a live demonstration on site as well once we're all able to travel again.
Yeah, thank you for that. So unfortunately, the time for the Q&A has ended. If we do not get your question, we are touching base with you directly, don't worry. So thank you, Christopher, Lucas, and Pat for today's webinar. We want to thank you all as well for attending our When Safety is Key, Addressing Safety Criticality in Modern Industrial and Transportation System webinar. On behalf of them and from CoreAVI, DISTI, and NXP, we want to thank you all. Shortly, you will get an email with details about the recording and the material used in this webinar. I am Tonio Hernandez, wishing you a great day. See you next time.